Hey everyone, I'm going to do a review of an audio amplifier IC, but before I do, I want to give you a thumbs up and thanks a lot for watching my videos. I do have one thing to say though. I do have some people commenting and I have no way to reply. And normally you get a reply button below each comment, but some people, they don't have a reply button. There's no way for me to reply. I mean, I could, go to your channel and, try to reply, or, Google Plus, but I'm not going to do that. If you want me to reply to your comment, I'd rather reply right in the comment section because it might help other people out. You have to make sure your Google Plus settings allow anyone to reply to your comments. I'm not sure where you go and set all that up, but just so you know, I can't reply to your comments unless you have that adjusted. Okay, on to the review of the TDA7052A 1 watt BTL mono audio amplifier with DC volume control. Ooh. Okay, what's this thing about? Well, let's say you have a voltage supply, power supply around 5 or 6 volts. You might think of using the LM386. It depends on your power requirements, your output power requirements and all that. Well, the problem at such a low supply voltage, you don't get a lot of output power. With an LM386, you're probably good for 200, maybe 250 watts of clean output power before clipping sets in. You could go to a 4 ohm load, but with the LM386 it really doesn't do that well with 4 ohm loads, and you might get a little bit extra power, but it's not really a recommended solution. Another thing with the LM386, it needs a fair amount of external components. You need, I don't know, at least 1, 2, 3, 4, maybe 4 or 5 capacitors to make it work if you use the gain function. And an input capacitor, you could use 6 or 7 capacitors. And you need a resistor or 2 as well. So, it needs a lot of parts to make it work. So what can you do? Well, enter this chip here, the TDA7052A. It's a bridge-tied load. That's what BTL means. In other words, it's just a bridge amplifier, a low voltage bridge amplifier. So you can use this amp with 5 or 6 volt supply, and it'll give you 1 or 1.1 or so watts of output, which is 4 times the output of the LM386. But that is, according to the data sheet, that's at 10%. I want to find out what the actual clean power is. It's saying here about half a watt at typical 0.3% distortion. So, that's quite a bit better. It's about double the power you'll get from a LM386, and the nice thing is it requires a lot less parts. Here is the internal kind of block diagram. Let's find the schematic here. Let me grab this here, go a little faster. Aha, here it is. So on the output, because it's bridge tied load, there's not that fairly large output capacitor you have to worry about. You can use a couple capacitors on the input supply. Normally I just use one. It's got this DC volume control we'll take a look at, see how that works. And you have an input capacitor. So really, that's just kind of a load resistor for the input. So if you have nothing connected, it won't oscillate. It kind of loads down the input. You really don't have to have that. I would recommend putting that in though to prevent oscillation if you don't have it, a music source plugged in and turned on. So yeah, you can really cut down the parts you need to make this thing work. And well, let's go take a look at the breadboard here and set it up and see what we get. Okay, all hooked up. Yep, that's it. Just two capacitors. There is a jumper. It has a nice feature that the power ground is over here and the signal ground is over here. But most chip amps, at least the ones I've tried, you have to have them bonded together or the amp may not work. I didn't try it without, but I'm going to assume that it needs to be bonded. Okay, have the music player hooked up, speaker hooked up, right to the outputs, no other components needed. Okay, that sounds pretty good. Let's take a look at that volume control feature. I didn't connect anything. Without anything connected, it just drifts up to its maximum voltage. But I don't have a potentiometer of 1 mega ohms necessary that it says it needs. Because if you connect something lower, it'll tend to drop off your volume or gain a little bit. Let me plug this 470K resistor in. It's got to go from the control to ground. And there we go. I don't know if the camera picked that up, but volume changed a little bit. Maybe I should try another resistor that has lower value. Well, here's a 100K. Let me plug that up and see what happens. Okay, I've put the 100 kilo ohm resistor across the output of the DC volume control to ground. Yep, when I took it out, it got a lot louder, so putting the load on that output pulls the voltage down a little bit and it drops the volume. So I took it out and it went back up. But normally I would just use the volume control on my music player, so you don't have to use that if you don't want. And there's just, hardly any components needed to make this circuit work. Pretty neat little chip. Okay, power test. I have the non-inductive 8 ohm resistor connected to the output. Input is a continuous 1 kilohertz signal, and the scope is hooked up, and we're metering that output. You can see if I turn it up, or clipping, one step down and it's not clipping anymore. Maybe just ever so slightly. The problem is one click on the volume control makes a big difference in the signal size. I really can't fine tune it without adding a potentiometer to adjust it. But you know, that's pretty good. I don't see a lot of clipping going on there. And we're getting 2.57 volts, I'll say. And I need a calculator, which is never around. I should have checked, but hang on a second. My Radio Shack vintage VFD calculator to the rescue. So we had 2.57 volts. There's no square key on this, but I just hit times equals and that'll square it for me. Divided by the load resistance or impedance, 8 ohms. And it puts out 825 milliwatts, or around 0.8 watts. That's pretty good. That's 3 to 4 times what the LM386 can do at the same supply voltage and load. It is a bit behind what the TDA7052A chip amp can do when it is running at 9 volts. The TDA7267 will do about 1 watt, and it'll handle 4 ohm load, giving you about 1.6 watts of clean power. But again, that's at 9 volts. This chip you can't really run at 9 volts because you know it's going to get hot. It's that little 8-pin dual inline package. If you want to push it though, you could probably add epoxy aluminum heatsink to the top of it, and maybe you can run it up to about 8 volts with the 8 ohm load, and that could give you I don't know, maybe a couple watts of output. Yeah, I don't know, maybe not quite that much, but be something I'd have to test. So, in conclusion, I say it's a neat little amp. So if you're limited on power supply voltage and you want to get a little bit more power than the LM386, consider this little bridge amp. Well, that's it. Thanks for watching.